Hello everyone. In this particular video we are going to be looking at partial fraction case 1 and case 3 and 4. Prior to now we've done for that of case 1 and 2. You can check our YouTube channel, that is Life Changer Tutorials, to get for that of case 1 and 2 in case you missed the first class. Now, remember, what is partial fraction? Partial fraction is the breaking down of complex fraction into simpler fractions. Okay. Now, for case 3, one part of the denominator is not factorizable. Is unfactorizable, not factorizable. Okay. Now, example. Break down the following into partial fraction. Now, how do I know I'm dealing with case 3? Look at this, for example. If you look at the denominator, this is x plus 1, this is a factor, this is s squared plus 1 is a quadratic expression. But this quadratic expression cannot be factorized. So when you see that one of the factors are not factorizable, this is how your expression is going to be. For this particular fraction, your breakdown will be a over x plus 1. Then plus, for this that is unfactorizable, it is going to be bx plus c. Once the denominator is unfactorable, it has to look like this, all over x squared plus 1. Okay. Now look at the next one. Before I solve, let's see the breakdown for these two. For the b part, for this guy here, okay, look at the denominators here. This is already a factor, but this cannot be factorized. It's unfactorizable. So how do I represent it? How do I break this down? For this denominator that is unfactorizable, we are going to have ax plus b all over x squared plus x plus 1. Then plus, for this other factor, we can now have a c all over x minus 3. I want to believe you understand that. Now look at for c, also two factors. This is unfactorizable, and why this is a double factor. Okay, so how do we represent this? For this that is unfactorizable, we have ax plus b all over x squared plus 4. Then plus, for this now double, you remember what we said concerning double factor. You're going to have c over x minus 2. Then plus AD all over x minus 2 squared because of repeated factors. That's exactly how you treat repeated factors. Okay, somebody may ask, will it always be ax plus b? No, depending on what it is. If the denominator is to the power of 3, let's say you have something like this, 3x minus 1 all over s cubed, let me say plus 2. This is not factorizable. We can't factorize this. So in this case now, the breakdown is going to be ax squared plus bx plus c all over x cubed plus 2, and so on and so forth. Okay, now let's see the solution to the breakdown. For the first one, we have 2x squared plus 1 all over x plus 1 x squared plus 1 to be equal to, we have a over x plus 1 plus bx plus c all over x squared plus 1. Okay, you remember what we did here. From this point, we can multiply each through by the factor of the denominator. The factor of the denominator here is x squared plus 1s squared plus x plus 1 x squared plus 1. But I love what one of you did by finding the LCM here. So that's another way we can go about it. We can decide to find the LCM of the denominators. Here we have x plus 1, and here we have x squared plus 1 at the denominator, the LCM of the denominators. Okay, x plus 1 cancels x plus 1 to leave x squared plus 1. So that times a will give us a into x squared plus 1. Then plus this x squared plus 1 can cancel x squared plus 1. So I'm left with x plus 1. So x plus 1 times this will give me bx plus c multiplied by x plus 1. Okay, After doing this, you see that the denominator here and the denominator here are now the same, so they can cancel each other. And I will be left with 2x squared plus 1 is equal to a into x squared plus 1, a into x squared plus 1, plus bx plus c into x plus 1. So at this point, here we have only one factor, which is x plus 1, so I can start with that. We can say let x plus 1 be equal to 0, which means x is equal to minus 1. Then substitute this value of this into the whole of this equation. So we can have 2 into minus 1 squared plus 1 equal to a into, this is minus 1 squared plus 1 plus, open bracket, b into minus 1 plus c, then here minus 1 plus 1. But I would like you to note, see here, minus 1 plus 1 is 0. 0 times every other thing here is 0. Okay, so meaning that this can be scrapped out. It's cancelled. This is 0. So minus 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. So we have 3 equal to, this is a into, minus 1 squared is 1. 1 plus 1 is 2. 2a. So what is a now? A here is 3 over 2. Beautiful. Beautiful. Okay, so let's see. Now we don't have any other factor to find b and c. At this point now, we can now assume. You can now assume numbers. I told you I prefer starting with 0, assuming x to be 0. Makes the job easy. So we can say let x be equal to 0. Any other number of your choice. Any number you use here, you are going to arrive at the same answer. Somebody else can say let x be 100. You are going to arrive at the same answer. But I usually use x equal to 0 because I arrive at my answer faster. Okay, so if I substitute x to be 0 here, I'm going to get 2 0 squared plus 1 equal to a into 0 squared plus 1, then plus b into 0 plus c into 0 plus 1. Do you get that? Now this is 0. 0 plus 1 is 1 equal to a times 0 plus 1 is also 1. Then plus b times 0 is 0. So I'm left with just c plus c times 1. Okay? So you have 1 equal to a plus c. At this point, you can remember that your a is 3 over 2. So we can substitute 1 equal to 3 over 2 plus c. So that means c is equal to 1 minus 3 over 2. Which when we find the LCM, 1 minus 3 over 2 is going to give us minus 1 over 2. I hope you understand. Okay, so we have 2x squared plus 1 equal to a into x squared plus 1 plus bx plus c into x plus 1. Okay, so we can choose 0. Let x be equal to 0. Sorry, any other number. 1. Okay, so we have 2 into 1 squared plus 1 equal to a into 1 squared plus 1, then plus b into 1 plus c, then 1 plus 1. Okay, so this will be, this is 2 plus 1, which is 3, equal to 1 plus 1 is 2, so we have 2a plus, this is b plus c into 2. Okay, so 3 equal to 2a plus 2b plus 2c. Okay, that is 3 into 2. A is 3 over 2 plus 2b plus 2 times c, as c is minus 1 over 2. So we have 3 equal to, this 2 cancels this, we have 3 plus 2b. 2 cancels 2 here, we have minus 1. So 3 equal to 3 minus 1 is 2, 2 plus 2b. So we have here to be 3 minus 2 equal to 2b, 1 equal to 2b. So that means b is equal to 1 over 2. So hence we can say that 2x squared plus 1 all over x squared plus 1 into x plus 1 is now equal to a. Our a is 3 over 2 all over s squared plus 1, then plus b. The b is 1 over 2, bx plus c. Your c is minus 1 over 2 all over x plus 1. Now the whole of this we can rewrite it as 3 over 2 into x squared plus 1, then plus this can be written as x minus 1 all over 2. They have a common denominator which is 2, all over 2 into x plus 1. Okay, so that now leads us to the second example. The second example here, we have 3x minus 2. 3x minus 2 all over x squared plus x plus 1, x squared plus x plus 1, and x minus 3. X minus 3. Okay. All of this now can be broken down into, as we said earlier, ax plus b all over x squared plus x plus 1, then plus c all over x minus 3. Okay, so which when we find the LCM here, we have x squared plus x plus 1 into x minus 3. So obviously this can cancel this out. I'm left with this, so this times this will give us ax plus b into x minus 3. Then plus x minus 3 cancels this to be left with this. This times this will give me c into x squared plus x plus 1. Beautiful. So if we cancel out the denominators here now, we are going to be left with 3x minus 2 equal to, here we have ax plus b into x minus 3 plus c into x squared plus x plus 1. So from here we can start by picking the denominator we have here. We have only one factor, which is x minus 3. So we can say let x minus 3 be equal to 0. That means x is equal to 3, and substitute that into our equation. So this is going to be 3 into 3 minus 2 equal to a into 3 plus b. Then we have here 3 minus 3, okay, plus c into 3 squared plus 3 plus 1. Okay, this is 9 minus 2, which is 7, equal to, this is 3a plus b times 0, which is of course automatically 0 here. Then plus, this is 9 plus 3, 12, 12 plus 1, 13, this is 13c. So we have 7 is equal to 13c, so it means c will be equal to 7 over 13. Good. So that leads us to find a and b. We can also continue with let x be 0. We don't have any other factor, so I can continue with x to be equal to 0. Substituting that here, we are going to get 3 times 0 minus 2 equal to a times 0 plus b. And we have 0 minus 3, then plus c times 0 squared plus 0 plus 1. Okay, this is going to give us minus 2 equal to a times 0 is 0 here. Then we have b into 0 minus 3 is minus 3. Then plus c into 0 plus 0 plus 1 is 1. Okay, so we are going to get minus 2 equal to minus 3b, then plus c. Now remember, we already have our c to be 7 over 3, so we can substitute the value for c there. We have minus 2 equal to minus 3b plus 7 over 13. Okay, if I collect like terms, bringing this here, I'll get minus 2 minus 7 over 13 is equal to minus 3b. Now, minus 2 minus 7 over 13, if I find the LCM is 13. I'm going to get minus 26 minus 7, which is minus 33. So we are going to get minus 33 all over 13 is equal to minus 3b. And when we divide both sides by minus 3, we are going to get b to be equal to 11 over 13. Beautiful. So that is now left for us to find c. Now, how do we get c? We can choose any other value. Let's say let x be equal to 1. And if we substitute that, we are going to get 3 into 1 minus 2 equal to a into 1 plus b. Then you have 1 minus 3 plus c into 1 squared plus 1 plus 1. Okay, so this is 3 times 1, 3 minus 2, 1 equal to, this is a plus b. You have a plus b, and here your 1 minus 3 here is minus 2, then plus c into, this is 3. Okay, so we are left with 1 equal to minus 2a minus 2b plus 3c. We can substitute our values. This is 1 equal to minus 2a minus 2 times b. b is 11 over 13 plus 3 times c. c is 7 over 13. Okay, so we are going to get 1 equal to minus 2a. This is minus 22 over 13. This is plus 21 over 13. Now, if we collect like terms, here, we are going to have 1 plus 22 over 13 plus 21 over 13 is equal to minus 2a. The LCM here is 13. Okay, we can write this as over 1. 1 in 13 is 13. 13 times 1 is 13. Plus 13 in 13 is 1. We have 22. Plus 13 in 13 is 1. 1 times this, we get 21. Equal to minus 2a. So we are going to have here 13 plus this is 35. 35 plus this is 56. So we have 56 all over 13 equal to minus 2a. If we divide both sides by minus 2, we are going to get minus, okay, we are going to get minus 28 all over 13, which is equal to a. At that point, we can write that 3x minus 2 all over x squared plus x minus 1, x minus 3 is equal to ax plus b. That means minus 28 over 13x plus b. B is 11 over 13 all over x minus 3. Then plus c, c is, we got our c to be 7 over 13 all over x squared. Oh, sorry. This is x squared plus x minus 1. Then y, this is x minus 3. So which we can rewrite as minus 28x plus 11 all over 13 into x squared plus x minus 1 plus 7 over 13 into x minus 3. Okay, that is how we got our final answer. Now we are going to move over to case 3 now. On your own, you can sort out the third question and send to me for verification. Now, when we get back to case 4, let's see case 4. Now, the case 4 could be case 1, 2, or 3, except that it is an improper fraction. Now, for case 1, 2, and 3, both case 1, 2, and 3, they must be proper fraction. They are proper fraction. What is proper fraction? A fraction where the numerator is less than the denominator.